In the vast universe of data analysis, we often find ourselves searching for meaning, for patterns that explain the world around us. Enter the realm of inferential statistics, a powerful toolset that allows us to draw conclusions about populations based on samples. At the heart of this toolbox lie t-tests, elegant statistical tests that empower us to compare averages or means and uncover hidden relationships between variables. Imagine you're exploring the effects of a new teaching method on student performance. You might want to know: do students exposed to this innovative approach score differently on exams compared to those using traditional methods? Or perhaps you're investigating a new medication and its impact on blood pressure. Does the medication lead to a significant reduction in blood pressure levels compared to a placebo? These are precisely the kinds of questions that t-tests excel at answering. Two of the most common types of t-tests are the independent samples t-test and the paired samples t-test. Each offers a unique lens through which we can examine and compare data, revealing insights that might otherwise remain hidden.
The independent samples t-test, also known as the two-sample t-test, steps in when we want to compare the means of two independent groups. These groups are distinct and separate, meaning that the individuals in one group are not related or matched in any way to those in the other group. This test is particularly useful in experimental settings, where we aim to determine if a treatment or intervention has a significant effect. For example, imagine you're a researcher studying the impact of caffeine on alertness. You might randomly divide participants into two groups. One group receives a caffeinated beverage, while the other receives a placebo. The independent samples t-test would allow you to analyze whether there's a statistically significant difference in alertness levels between the caffeine group and the placebo group after consuming their respective drinks. Let's break it down with a practical example. Imagine you're interested in understanding if there's a difference in average height between men and women. You could collect height data from a random sample of men and a separate random sample of women. The independent samples t-test would then help you determine if any observed difference in average height between these two groups is statistically significant or simply due to chance variation.
Unlike the independent samples t-test, which focuses on differences between groups, the paired samples t-test delves into changes within the same group or between paired observations. This test is particularly powerful for assessing the effectiveness of interventions or treatments over time, or for comparing measurements taken from the same individuals under different conditions. Consider a study investigating the impact of a new exercise program on weight loss. Researchers could record the weights of participants before they start the program, and then again after several weeks of participation. The paired samples t-test would allow for a direct comparison of these measurements, revealing whether there's a statistically significant difference in weight before and after the exercise intervention. Another common use of the paired samples t-test is in analyzing data from matched pairs. For instance, imagine you're studying the effectiveness of a new teaching method. You could pair students based on their pre-test scores, ensuring that each pair consists of students with similar initial abilities. One student in each pair would then be randomly assigned to the new teaching method, while the other receives traditional instruction. The paired samples t-test would help you determine if the new method leads to a significant improvement in learning outcomes compared to the traditional approach, taking into account the initial pairing of students based on their pre-test scores.
Imagine a line graph showing the average weight of a group of people before and after an exercise program. The x-axis, labeled time, has 2 points before and after. The y-axis is labeled average weight in kilograms. This simple visualization can help you clearly see the impact of the exercise program over time.
Understanding your data is like unlocking a treasure chest. By diving deep into the numbers, you can uncover patterns and insights that were previously hidden. This process not only helps in validating your hypotheses, but also in making informed decisions based on solid evidence.
T-tests are not just confined to academic research, they have real-world applications too. For instance, in the healthcare industry, they can be used to compare the effectiveness of two different treatments. In marketing, T-tests can help determine if a new advertising campaign is more successful than the previous one. The possibilities are truly endless, and the insights gained are invaluable.